Now we're talking product development and the new era for product development. As we all know, the goal of developing products is to build something that the customers want, the right products, and we want to put them on the market at the right time, and also at the lowest cost. Oh, by the way, you have a limited budget, and of course limited resources. You have no time at all. Your priorities change, and mostly on a daily basis. You should get a headache of less problems. One rule, the first rule of the 5 golden rules, you have to make a plan, to create a plan for your own company, fit to your own goals and purposes. And this has to be a strategic plan because it has to cover all business processes, so it involves a lot of stakeholders. Now, as a company, what kind of options do you have? Well, you can do nothing. That's a valid option, which means that you're, on the left-hand side, you can see that profit or margin or turnover. You will see it decrease gradually in the beginning and steep at the end. Another thing you can do is making some incremental improvements. And this is typical, let's say, keep the business running as it is running right now. Business as usual. We fine-tune it, we tweak it, we make some minor changes to keep it running at the same level. And then, the third option, why not go for this breakthrough innovation, make a, let's say, a substantial improvement. The room for improvements will not increase when you do nothing. So with this incremental improvements, you will just try to fill this room by tweaking and fine-tuning. What you have to do is create some additional room where you can innovate and realize some growth for your company. The first thing then is, okay, we have to set some strategic goals. That can be time to market. Key is, or a lead time is the key factor, I hear all the time. First time through rate. First product going through must be correct. Customer satisfaction, less complaints. That's what keeps you awake at night. Even complexity, product performance. Efficiency, that's our goal that we want to improve. Or flexibility. Smaller series. And of course, the classic cost reduction and higher margins. When you have set your goal on 1 or maybe 2 or 3 of those areas where you want to improve, to remain competitive, you have to go through your business processes. And there are a lot. I've mentioned here some, not all of them, and some may be relevant for your company, some not at all. But that's not the issue here. The issue is that this, it can be complex because you are talking about many processes, many stakeholders, many people, many opinions, and many softwares. This is what some consulting firm came up with to explain the situation in Afghanistan. It was for the US Army. So they draw up all the stakeholders and put some relationships between them. The reaction from the general was, well, when we understand this slide, we'll have won the war. Okay. What I'm trying to say is, at the beginning of this month, I was in Germany. I'm sure when they see this slide, they say, wow, sieht gut aus. Huh? So it's all a matter of, I'm not saying that this is not good, but things can be complex. And you have to find a way to visualize this complexity and set your priorities. This is again very straightforward. This is one business process, as you all have. That's a very, very small part of it, and it has to do with engineering. What you can do is map your strategic goals above it. In this case, the company was very much interested in lead time. They had to get their products faster to the market. So we draw that up. You can use a lot of softwares to do that. I mentioned here some. I can assure you Excel, PowerPoint, Visio works as good as any of these other softwares to map your, or to visualize your business processes. When you want to do some simulation with it, when you change one thing, how everything else changes, then you may need some more complex software. Okay. So when you have analyzed these processes, you will get some problems or issues. And those are mentioned on top of this matrix. And you have to develop some actions to tackle the issues, to improve them, or create some other opportunities. And in the center of the matrix, you can indicate the impact of one action on the several solutions. So in this way, you get a clear view of when I change something in production, what it will affect in product development, or maybe maintenance or sales. And then, of course, you can, when you get these actions, you can prioritize them according to whatever parameter you would like to see it prioritized with, be it lead time or the return on investment or the energy you have to put into one action. The question now is, okay, what kind of actions can we do in the digital factory or digital manufacturing or digital enterprise, or let's say in a digital environment? The most logical one, eliminate steps. Sounds very normal. Increase the efficiency of certain steps. And the killer, which always hurts a lot, are those useless iterations. Something comes back because it was not designed properly the first time. Then at the end of the assembly line, they say, okay, this was not what we had in mind. For those actions, you have to think digital. That's the second rule. And you can do that in many ways. Here again, you see a mapping of several tools for simulating the specific business process. So you can do that for styling, for example. You can do that very much in a digital way. You don't need a physical prototype to assess the validity of some part, or tooling, or molding. Even the flow in production, how the goods will move through every step, robotics. It can all be very much done in a virtual way. There are a lot of softwares, but also technologies. I'm not here to discuss all the types of software. I'm just saying they are there. It's one aspect of a digital factory. Technologies is another one. I mean, when you can put a robust flat screen in production, so nobody needs those 2D drawings, it's just a matter of technology. Now, what kind of technologies are there? 3D scanners or cameras, they are becoming very, let's say, not cheap, but the price over the last 3 years has halved. So that's good. So those robust screens for production or assembly lines, maintenance, barcodes, mobile phones, smartphones. This was also one conclusion of those let's say, IT vendors, not just PLM, but also SAP and Microsoft were present. Everybody is going to be mobile in the near future. You can, let's say, here one guy from maintenance, just do it mobile, get the manual, get the instructions, get the customer overview, even virtual. And let's say the last one is more or less specific for automotive, but don't exaggerate in all these things. I mean, the webcam is obsolete there on the top. This one is, it's a very nice picture. I put it in the slideshow because a lot of information is going from engineering, product development, to marketing and sales. They say, we need a nice picture. So then one engineer waits until the physical prototype is finished, then takes a picture and sends it to marketing. This is fully digitally done, so there's nothing, no prototype available. And you can see that the glasses, the dices, the blue dices, and the green ashtray, well, it's very well done. You can see the difference between reality and then the virtual glasses. And here you can save a lot of time, effort, and money. So this rendering is becoming more popular to get the brochures and the catalogs even before there is a physical part. Is this digital factory only for large companies? Not at all. We had some project at Quai Orthopedic Services. What do? They make some mattresses or seats for, let's say, disabled patients with some arms in a specific direction. It was a very plaster-intensive company. They have to measure the geometry of the patient, make it some plaster, make the negative, and then do some copy milling, and then cover it with some leather or whatever it was. Very long lead time, also labor-intensive. What did he do? He assessed the patient geometry with a 3D camera. So then you start with a cloud of points. You can take that easily into a CAD system, do some CAM operations, and then send it to the milling machine. And you can see there is no plaster left in that company. Lead time reduced drastically. Another example from Ranson. You all know that company. They make some, let's say, louvers, they call it, for windows. Original process, actually make the parts, physical prototypes, send it to England for testing, and then hope that tests are okay. Okay, you might as well simulate that and see how the drops then eventually form and go to the lower Louvre. So in this way, you can save a lot of time. Now, this was not a success. I see you think, why? It looks beautiful. Well, it's not about the looks. This case was very difficult because in simulation, when it comes to multiphysics, where you have several physical processes, to simulate that, it's not easy. And you have to rain droplets by the wind, the cohesion on the material,